All right, welcome. So, following up our series on elasticity, let's say we have this problem. It says a spiral spring loaded with a piece of metal extends by 10.5 centimeter in air. When the metal is fully submerged in water, the spring extends by 6.8 centimeter. Question says calculate the relative density of the metal. Okay, so let's say we have this to be the spring. Okay, this is the spring, and then in air it is loaded with a piece of metal. Of course, this metal has a mass, and this mass will cause this metal to have a weight that acts vertically downward. So this is the weight of the object in air. Now, of course, if we do a force system or a free body diagram of this system, we are simply going to have this. Okay, this is the mass, and of course the spring force will act upwards, and that spring force is simply given as F equal to KE, not forgetting where E is the extension, F is the force constant, then the weight of this object will act vertically what downwards. This becomes this becomes the equilibrium diagram or the free body diagram for this system. This is the spring and this is the mass. This mass will have a weight that acts vertically downwards, and of course we all know what weight is. And then if you draw the free body diagram, you simply have this. The force of the spring is simply what F equal to Ke from Hooke's law. Force is simply F equals spring constant times what the extension or the stretching. Meanwhile, the weight of every object acts vertically downward. So this becomes the free force system of um, this diagram. Okay. Okay. So this force is now equal to recall, since force is equal to spring constant times extension. We weren't given the force, and of course, we were given the value of the extension. So in air, this is the condition in air, not forgetting this condition in air. So in air, the material extends by what 10.5 centimeter. This extension is simply what this E, okay, where E equals 10.5 centimeter. That is in air. Okay, so you simply have this. So this simply implies that F is now equal to what? K times 10.5, which is simply 10.5 times K. That gives us a value for the force. Now, for this system to be in equilibrium, this system to be in equilibrium, it means the weight must be equal to what? The spring force. For the system to be in equilibrium, this is weight in air. So this is in air atmospheric condition. So this is weight in air. The weight in air must be equal to the what? The spring force if the system must be in equilibrium. Okay, so for equilibrium, okay, we simply have that F must be equal to weight in air. And this implies now, we know the value for F. F is simply 10.5 K. So this simply implies that 10.5 K is equal to the weight of the object in air. So you keep this equation aside. So the weight of the object in air or the metal in air is simply what 10.5 times K. Now, the second condition says that if the metal is fully submerged in water, so if this metal is fully submerged in water, we can have a different condition for it now. Same thing, you have your spring, okay, and you have this metal, but in this case, this metal is actually submerged in water. Okay, let's simply call this water. It doesn't see change. The weight of this metal will act vertically downwards. Doesn't see change. The weight of the metal will act vertically downward, but this is now weight in water. So this is what in a water condition. So that becomes the weight in water. Okay, and of course, if we draw the free body diagram or the equilibrium diagram of the system, it's still the same thing. You simply have what the mass, the spring force, of course, still remains K times E, and the weight now is now weight in water. Okay, and you simply have this. So what then is the spring force? Remember, it was even here that when it is fully submerged in water, the spring extends by 6.8 centimeter. So the extension is simply what 6.8 centimeter, which means E, um, okay, in water, okay, the extension E is equal to 6.8 centimeter. So you simply have this. So if this is the extension in water, then it means the spring force in water, force is simply equal to, remember it is K times E. E is now equal to, in place of E is 6.8. So you simply have 6.8 times K. Okay, this becomes the value for the force in water. All right, so for equilibrium as well, for equilibrium to be achieved, it means weight in water must also be equal to what? The spring force. Okay, for equilibrium, okay, the force must be equal to the weight in water. So this simply implies we have the force to give us 6.8 K. We simply have 6.8 K equals weight in water. So keep this aside. So this simply means that the weight in water is actually what? Given us 6.8 K. But the question says we should find the relative density. What then is the formula for relative density? Okay. Okay, so relative density, okay, R dot D can simply be given as weight in air, mathematically can be given as weight in air all over weight in water. Okay, all over weight in water. So simply, relative density is simply equal to W air all over W water. So R dot D is now equal to the weight in air. We obtain the value for weight in air to be what? 10.5 K. Weight in air is simply 10.5 K. All over the weight in water, we obtain the weight in water as 6.8 K. All over 6.8 K. So from here, of course, it is obvious the spring constant cancels out. That means relative density is actually what? 10.5 all over 6.8, which implies that R dot D is now equal to, that simply gives us 1.5441. Okay, so this becomes the value for the relative density. Okay, all right guys, so I hope you find this video very interesting and helpful. Please, if you do, I would like to get your thoughts in the comment section, and of course, if you're new to the channel, don't forget to hit the subscribe button to keep getting updates on all our videos and contents on this. Thanks and cheers.